Now, you all are no strangers to the fact that James Webb Telescope is able to detect a lot of huge, incredible visuals of stars, galaxies, multiverse, maybe. Not yet, we've not gotten into that. However, it's really fantastic to see how sensitive this particular instrument is, not only in terms of how further it can view things, but you know what, other things that it can actually catch that you might not actually expect, little small things. And this actually comes into play where you look at this article which was published by NASA, and it talked about, hey, have you imagined you detected an asteroid, and not only that, this asteroid is that small, like for example it says that between 300 and 650 feet, or around 100 to a 200 meter long asteroid. Now, in terms of visualizing it, it says that it's about the size of the Roman Colosseum, and so that is really fantastic to actually visualize that, and how this asteroid was detected by the James Webb Telescope. Now, if you might be wondering what particular part of the James Webb Telescope is able to capture this image that far away or asteroid, you can actually see from this article that it says that it used the middle infrared sensitivity part of its cameras to be able to capture this asteroid. And the one challenge is that this asteroid is known to be around the asteroid regions between Mars and Jupiter. And looking at that, you might be wondering, whoa, this is really far away from where this particular telescope is located at. And it says here, according to this article, that according to astronomer Thomas Muller, we can thank Webb's incredible sensitivity for allowing us to see this tiny object at a distance of more than, guess what number, 60 million miles, which is around 100 million kilometers away from where it is positioned, which is the James Webb Telescope. So that number is really critical, because being able to be that sensitive using the mid-infrared region to detect small particles like the asteroid, in that case, based on the scale, is really fascinating. And there was a little bit of a test on that when DOT colluded with Dimorphos, and we had that visual take from James Webb Telescope that caught the real-time impact. And that is one way by which you can actually survey various areas around our solar system, specifically looking at Earth, and what are the little threats that are going to be coming from different parts of the solar system that may impact our Earth. And seeing something that far away can actually get or give us enough time to know, properly prepare for any impact that may come, and maybe we can have enough time and with the right surveillance and probability technologies that we can figure out in terms of what is the possible path of the asteroid and chances of it coming to our own specific space, and also maybe making an impact that can give us enough time to make those projections and determine what actions can be taken as quick as possible. So it's really fascinating to see how James Webb Telescope is going to be a great foundation, and this foundation can be built on to improve on this technology, and for we to be able to add more sophisticated tools to future telescopes, and those will enhance the beauty of exploration of our solar system and beyond. Now, the designated name for this asteroid is 10920, and this is located at the middle belt at that particular region of Mars and Jupiter. So looking at these in details, you can see based on the mid-infrared region and the analysis and data that was collected, the team found a smaller interloper in the same field of view. Now, the team results suggest that the object measures around that particular meters of 100 to 200 meters, occupies a very low inclination orbit, and was located in the inner middle belt region at the time of the Webb's observation. Now, this is going to be interesting to see how you might think that creating an instrument will do specific things, and you've actually had that pinpointed already, but little do they know that this instrument will do more, or will provide more functionality in terms of what they can combine those data that they have together. Furthermore, in this article, it says that our research shows that even failed Webb observations can be scientifically useful if you have the right mindset and a little bit of luck. Elaborated by Mueller, our detection lies in the main asteroid belt, but Webb's incredible sensitivity made it possible to see this roughly 100-meter object at a distance of more than 100 million kilometers. Now, the detection of this asteroid, which the team suspects to be the smallest observed to date by Webb and one of the smallest detected in the main belt, would, if confirmed as a new asteroid discovery, have important implications of our understanding of the formation and evolution of our solar system. But small asteroids have been studied in less detail than their larger counterparts, owing to the difficulty of observing these objects. Future detections of Webb's observations will allow astronomers to study asteroids smaller than 1 kilometer in size. What's more, this result suggests that Webb will be able to collaborate to the detection of new asteroids. The team suspects that even short, middle infrared observations close to the plane of the solar system will always include a few asteroids. More of them will be unknown objects. Now, in order to confirm that the object detected is a newly discovered asteroid, more position data relative to the background stars is required from follow-up studies to constrain the object's orbit. Now, this is really a fantastic result which highlights the capabilities of the mid-infrared to detect a previously undetectable size of asteroid on the main belt, according to Brian Hula. And Webb supports scientists at the Space Telescope Science Institute in Maryland. Repeats of these observations are in the process of being concluded, and we are fully expecting new asteroids interlopers in those images. So I hope you found this article and this analysis informative. Hit a comment down below. Let me hear your thoughts about what are the hidden powers that James Webb Telescope might have. What other things do you think it can detect? What are the uses or more important things other than all the things that we'll be looking at on our previous videos? And how can these be a revolutionary, impactful use of this telescope in future explorations of not only our solar system, of course, but our universe? All the same, hit a comment down below. Let me hear your thoughts about this. By that way, I can talk to you soon. Stay smart as always and believe in yourselves.